Hi everyone, my name is Lauren Moore, and today I'm going to be talking to you about my project titled Vulnerability to Climate Change of the Longleaf Pine Ecosystem at Fort Benning, Georgia, a Rapid Assessment. So I found this really cool tool published by NatureServe called the Climate Change Vulnerability Index. It is a tool designed to specifically help land managers create strategies that take the impacts of climate change into consideration. It uses methods that are supported by published studies to devise its scoring metric and uses three components of vulnerability. The three components of vulnerability that the index takes into consideration is indirect exposure to climate change, species-specific sensitivity and adaptive capacity, and documented response to climate change. The index works by producing a numerical sum, which is then converted into a categorical score that they have devised. It takes the three components of vulnerability to climate change and breaks them up into different factors, of which the assessor then determines the effect of. You can see here factors that influence vulnerability, and then the assessor chooses the effect on vulnerability that will have on the specific species, ranked from neutral, somewhat increase to greatly increase. And then the six possible scores that will come at the end of it are extremely vulnerable, highly vulnerable, moderately vulnerable, less vulnerable, or insufficient evidence. So I decided to focus my project on the longleaf pine ecosystem that was once very prevalent in the southeast, covered almost 92 million acres. Today that has been reduced to about 3% of its historic range. That's due to a lot of changing land use over decades, agricultural fields, industrial and urban development, a lot of heavy fragmentation that has interfered with the much needed fire regime. It is considered one of the most biologically diverse habitats found in the world, and it's home to some 29 threatened and endangered species. So the index guidelines state that this index or this tool works best if you're analyzing an area about the size of a national park. So I decided to focus my efforts on Fort Benning, Georgia, since there's a lot of restoration efforts or have been in the past going on out there, which did ramp up around 2010 when they started planting about 2,000 acres a year at about 600 trees per acre. Of course, their focus out there is providing suitable habitat for the federally endangered red-cockaded woodpecker, as well as sufficient training areas for the military. So once I decided that, I formulated my question, which was, how vulnerable are the longleaf pine ecosystems of Fort Benning, Georgia, to the effects of climate change? I then hypothesized that given the longleaf pine ecosystem's tolerance to drought and ability to withstand drastic temperature increases, paired with the intense management focus of the area, the longleaf pine ecosystem of Fort Benning, Georgia is expected to score in the less vulnerable range on the Climate Change Vulnerability Index. So now I'm going to go a little bit into my methods and how I adapted this index to my project. When NatureServe published this tool, they also published with it a guidelines booklet to help the assessor, through every step of this assessment tool. It's super, super helpful. So it kind of just lays out everything for you. Step one that they list is determining your assessment area and the species distribution within that area. Since I decided to go with Fort Benning, I actually found this very helpful map provided by the Nature Conservancy, where they outlined the area of Fort Benning as well as the vegetation cover. You can see everything in yellow is considered longleaf pine habitat. For the considerations of my project, I guess, lesser knowledge of all of the species there. I'm not a specialist in any of them by any means. I just determined that if there was longleaf pine, then there was also the various other species that I was looking at for this index. Speaking of, so these are my species of focus. It's impossible for me to obviously assess every species found within the longleaf pine ecosystem of Fort Benning, Georgia, so I decided to focus my efforts on a few big ones, a lot of varied species. So we have some plants, some different types of animals. I decided to look at the longleaf pine, the wiregrass, red-cockaded woodpeckers, the gopher tortoise, and the eastern indigo snake. So step two in the guidelines for using this index is gather the life history data of the focus species. These are just a few examples of the information that I had to find: dispersal and movement ability, physical specificity, geological features, interactions with other species. This was by far the lengthiest part of my project. The guidelines actually state that in a perfect world, doing this assessment in the real world, you would have sort of this super task force of scientists, all which specialize in the individual species. So I would have a longleaf pine specialist. I would have a red cockaded woodpecker specialist, a gopher tortoise specialist. Since it was me, I did a lot of reading, a lot of different papers, and utilized the resources that I had in order to best answer these questions for the index. So step 3 involves gathering the climactic data for the assessment area. Luckily, since my area is pretty small, obviously the climate doesn't really change over Fort Benning. I use the Climate Wizard tool, which is suggested by the index guidelines, and I gather the climactic data needed for the index. Okay, and step 4 just involves applying all of the data that I found to the Climate Change Vulnerability Index. And the instructions very well laid out and provided in that guidelines document as well. Okay, so the tool is actually programmed into a Microsoft Excel workbook, which the assessor then fills out. So the first section here is where you input your climactic data that you gather from the Climate Wizard tool. First thing that you fill in is the temperature and the expected temperature change by the year 2050. This is where you would normally put the percentage of your range that's going to fall into those categories. Again, since I did such a small area, 100% of my assessment area fell within the expected to see a less than 2.2 degrees Celsius warmer by the year 2050 change. Here we have the Hammond EAT-PET moisture metric, which is a metric that takes into account precipitation changes based on the temperature changes. Again, 100% of my assessment area all fell within the same range. And then down here is migratory exposure. None of my species were migratory, so that's something I didn't have to worry about. So section B of the tool takes into account indirect exposure to climate change. You can see here the factors that influence vulnerability, and then to the left you can see the effects of vulnerability, and that's where you rank the factors. So the first one, like exposure to sea level rise. Every single one of my species in this analysis, I rank that as neutral. Since we're so far inland, that's not really going to be a big factor. Then when you go down to like distribution barriers, natural barriers versus anthropogenic, and the guideline gives pretty detailed guidelines for how you should score these. You are able to put multiple responses in, so you can see here for natural barriers I put neutral and also somewhat increase, because I just wasn't sure. Like I said, I'm not a specialist on any of these. Also, I tried to take into account the management aspects on Fort Benning. So, you know, it's one of their key focuses is to protect this habitat. So, you know, some of these things I ranked as neutral, some of them somewhat increase, just because I was unsure of the variation that could take place. Okay, so section C of the index here are all of those life history pieces of data that I had to look up. So you have like your dispersal, dietary versatility, dependence on other species, sensitivity to pathogens and whatnot. And again here, you can rank them. You can put multiple scores for each. So it just varied. Some of them were similar across the board for my species, such as the hydrological niche, physiological thermal niche, historical thermal niche. All of those didn't vary between the species, but different things like dietary versatility, pollinator versatility, obviously, in my plants versus my animals, some sensitivity to pathogens. I found some cool papers on some diseases that affect some of my species that I wasn't aware of that climate change could exacerbate by raising temperatures. I think a big factor that played into some of my species scoring higher in vulnerability is their interspecific interaction, or the fact that they required other species to generate the habitat that they required. Okay, and then step 5 is just to interpret the results. So the tool runs a Monte Carlo analysis to estimate the confidence in the overall score, and also creates a histogram to summarize the frequency that each vulnerability score resulted from the simulation runs. Okay, so now I'm going to show you what those results look like. Okay, here you can see the results for the longleaf pine, which scored in the highly vulnerable range. So the Monte Carlo simulation runs 1,000 times with the data entered into the index, and it shows about an 83-84% likelihood of that falling into the highly vulnerable range over those 1,000 runs. So the confidence in that vulnerability index score was high. Okay, next we have the results for the wiregrass, which also scored in the highly vulnerable range. This confidence score was a little lower at moderate. That's showing that over the 1,000 runs of the Monte Carlo simulation, about 67% of the time it scored in the highly vulnerable range, with about 24-25% of the time falling in the moderately vulnerable range. Here we have the data for the red cockaded woodpecker. Looks kind of similar to the wiregrass results. Again, it did score in the highly vulnerable range with a moderate confidence in that score. You see about a 60% chance of that falling in the highly vulnerable over the 1,000 runs of the Monte Carlo simulation, and then a 40% chance of falling it in the moderately vulnerable. Okay, next you can see here we have our results for the gopher tortoise, which also scored in the highly vulnerable. This one also had a moderate confidence in that vulnerability index score. It's got about a 79% chance of falling in the highly vulnerable, with about a 21% chance falling in the extremely vulnerable, and about a 1% in the moderately vulnerable. Okay, and last but not least is our eastern indigo snake. It actually scored in the extremely vulnerable. It had about an 82% chance of falling in that, with about an 18% chance falling in the highly vulnerable. That did create a high confidence score in that vulnerability index score. Okay, so overall, the longleaf pine ecosystem located at Fort Benning, Georgia, scored in the highly vulnerable range on the Climate Change Vulnerability Index with a moderate amount of confidence, which is very different from how I thought it would score. I did try to take into account the high amounts of management that go on Fort Benning. Obviously, this is an ecosystem that they have purposefully restored and tried to protect. I don't know that that is necessarily reflected in the outputs that I received, but I think that's definitely due to my just lack of knowledge of these species. I mean, I did do a lot of reading, I did do a lot of research to try to answer these questions as best I could. I do see the benefit of maybe having a specialist that really knows these species in and out come in and maybe run this assessment tool with their knowledge. I think that would be really beneficial. But yeah, I mean, it was really cool to learn how to use this tool. I think it's really beneficial. I actually have found, like, the National Park Service has used this in various published things that they have done. A lot of, like, nonprofit organizations and governmental organizations use this tool. So it's definitely something that, you know, we as environmental scientists might encounter in the future. And it was just really interesting to see how it worked and see the outputs that it gave me. Here are my millions of references, and I had a lot of fun doing this project. Thank you.